and a very welcome again to assessment of the fetal status using the cardiotocograph series. I'm still Anna Nolte, and today I'm going to teach you on the interpretation of the normal CTG cardiotocograph, and we're going to do the periodic changes, accelerations and decelerations. We're going to talk about the normal characteristics of contractions, and then I'm just going to go through the normal antepartum CTG with you and tell you what we are looking for in the interpretation of an antepartum CTG. Now, when we talk about periodic changes, the name tells us what it is. From period to period, there are some changes in the fetal heart rate, and we have two types of periodic changes. The one is accelerations and the other one is decelerations. Accelerations is the definition. It's an increase in the fetal heart rate of more than 15 beats per minute for longer than 15 seconds. So it's not just a quick squirrel on the CTG graph, but it lasts for at least 15 seconds. And this is a very good sign of the integrity of the somatic nervous system, as we've said in lesson 4 when we did the physiological changes, and it's often associated with fetal movements. And we are very happy when we see accelerations during the antenatal period, because that gives us a reactive pattern, which we will come to. And if we see it during labor, we're also very happy. Here you can see an example of accelerations. They are all marked with a yellow highlighter. If we look at the definition of an acceleration, we've said it's when the fetal heart rate accelerates with more than 15 beats per minute for longer than 15 seconds. Now, if we look at this acceleration, for example, here you can see more or less is the fetal heart rate is 130 beats per minute there. There's 140 beats per minute, there's 150 beats. So in this case, the fetal heart rate accelerates from about 130 beats per minute to 150 beats per minute. Here you can see also more or less 130 here, and it accelerates up to 150, just above 150 even there, and they're almost up to 160 beats per minute. Now, if we look at the duration here, remember we've said we have to determine, when we want to determine duration of anything, we need to first of all look at the speed of the rate of how fast this paper has gone through the machine, and it should be set here. It might be a little bit small for you to see, but it's 1 centimeter per minute. And we've said usually where the distance between these two darker lines is usually a centimeter. So this distance here would be more or less a centimeter, and this distance here is a little bit longer than a centimeter. So both these accelerations last about a minute long. These ones looks like almost like half 30 seconds and 30 seconds. Now, the other important thing that you see on this slide is this patient is in labor because there are contractions here. We have said that we always want to see accelerations during an antenatal CTG, because that tells us that the fetus is awake and his somatic nervous system is working because he moves, and when he moves we get accelerations. Now, and we also said that sometimes during labor these accelerations disappear. But here we can see is a graph of a fetal heart being done during labor where we have accelerations. And so we're very happy. If we look at this CTG, it has a normal heart rate of about 130 to 140 beats per minute. There's good variability, and we even have accelerations. So a happy graph. Now, if we look at decelerations, then the definition is similar to the accelerations. It's slowing, it's a transient or a temporary episode of slowing of the fetal heart rate below of more or less 15 or more than 15 beats per minute, and it lasts longer than 15 seconds. And we get three types of decelerations. We get early decelerations, we get late decelerations, and we get variable decelerations. When in lesson 6, when we discuss all the abnormalities regarding the fetal heart patterns, we will discuss each one of these in more detail. Now, whenever we look at the deceleration, and it doesn't matter which one of those three it is, there are always certain characteristics again of the deceleration that we look at, because that gives us an indication of how serious or not the deceleration is. Now, first of all, we look at the form of the deceleration. In some cases, the form is a sharp form like in here. In some cases it's more a U form, and also what's very important to us is, do they all look similar? Do they look uniform in form, or are they different? And we will come to variable decelerations, for example, might all look different, so they're not uniform in form. Then also very important is the time relationship between the contraction and the deceleration. When does the deceleration start? Where's the peak of the deceleration according to the peak of the contraction? And when is the deceleration going back, the fetal heart rate going back to the normal baseline? Then, and we will discuss every one of these when we come back to the interpretation of all these decelerations in lesson 6. And then the amplitude of the deceleration. How deep does this deceleration go? How much does the fetal heart rate fall in numbers, if I can call it like this? So here's the fetal heart rate is about 140 beats per minute, and it goes down to 110 beats per minute. So there's a deceleration of about 30 beats per minute. And then lastly, the very important aspect here that we need to look at is how quickly does the baseline return back to the baseline? How quickly does the fetal heart rate return back to the baseline? Now here you can see it returns fairly quickly. Sometimes it takes quite a long time to go back to the baseline, and that's also more serious than when it returns quickly. Now, when we look at the contraction pattern on a CTG, like we've said in lesson 3 when we did the internal and the external CTG, we've said when we use the external CTG, we can only interpret the frequency very accurately, and we can determine whether the contractions are going back to the baseline. We've said that you can only with the intrauterine catheter in the internal method, you can determine the amplitude of the contraction accurately, and you can determine the duration of the contraction accurately. In the external method, we can more or less see how long the contractions are, and we can more or less see how strong the contractions are, but we can't determine that accurately. The only thing that we can determine accurately is over a period of 10 minutes, how many contractions are there, and that is what we call the frequency. And just to remind you about the baseline, we've said that when we set up the machine, we set the baseline of the contractions on the machine between 10 and 20 millimeters mercury. And the reason for that is, it also again doesn't tell us accurately what the basal tonus in the uterus is between contractions. We can't do that accurately with the external method, but we can internally. But here, if we set the baseline, and here it's been set on 10 millimeters mercury, we can see that the uterus relaxes every time to more or less 10 millimeters mercury, so that the pressure in the uterus comes back to where it should be between the contractions, which is also very important when we think about the basal tone. Remember what we've said, the intrauterine intraplacental circulation, where the circulation is the uterine arteries are being blocked off, or occluded during the duration of a contraction. Now, if it happens that the contractions are not coming back to the baseline, they're going, for example, like this, it means that those maternal arteries will not open at all, or they will only open when the contractions are coming back to the baseline. We will come back to that again later as well. Then if we just quickly look at the antepartum CTG, or what we also call the non-stress test, it's based on the principle that the fetal heart rate will accelerate with fetal movements. And those are usually the things that we are looking for. You will see here we talk about a reactive pattern. Reactive means, the name exactly says what it means. The fetus is reactive. We get a baseline of 110 to 160 beats per minute, which is a normal baseline. We get good baseline variability of more than 5 beats per minute, which tells us that the parasympathetic and the sympathetic nervous system gets enough oxygen, because we said that if they get enough oxygen, there's usually good fluctuation between the parasympathetic and sympathetic nervous system, and that's where the variability comes from. And then the third very important thing here, the presence of accelerations together with fetal movements, is very important for us. And we usually look for 2 or more accelerations of more than 15 beats per minute over a period of 20-minute period. So we look for accelerations that's more than 15 beats per minute for longer than 15 seconds over a 20-minute period. So we say a pattern, a non-stress pattern or an antepartum CTG pattern is reactive if the baseline is normal, if there's normal baseline variability, and if there are 2 or more proper accelerations of more than 15 beats per minute and lasting longer than 15 seconds over a period of 20 minutes, then we are very happy. And here you can see a typical reactive pattern. Here we see a normal baseline of about 120, just above 120 beats per minute. I would say 125 to 130 beats per minute. There are some good accelerations there, and then also there's good variability. This CTG has been done over a period, or the speed of the paper is 3 centimeters per minute. And that's why you will see the variability looks a little bit stretched out, but it's still, if you look carefully, you will see it's more than 5 beats per minute. And the accelerations also look a little bit drawn out. But again, it's because the speed of the paper is 3 centimeters per minute. And here you can see the fetal movements have been marked, and every time when there was a fetal movement, there was an acceleration as well. And that again brings us to the end of lesson 5. And by now, you should be able to know all the normal aspects of a CTG graph, and you should be able to determine whether a CTG at least is normal or not. Okay, and it's quiz time again. I'm sure you will do well in this quiz. Enjoy, and I hope you've learned something.